Hello, everyone. My name is Kellen Potocsnak, and I'm here to talk to you today about spooky poems. My project was centered around 70 short stories from Edgar Allan Poe, including popular titles like The Black Cat, The Telltale Heart, and The Pit and the Pendulum. Viewed as one large corpus, these stories had 24,775 unique words and 103 unique characters. And despite its reputation for dark and arcane language, Poe's most used words were actually very commonplace, with "the" being the most used word in the entire corpus. I used an LSTM model to predict on a sequence of encoded words and return a one-hot encoded vector, indicating the next predicted word in the sequence. I adjusted the model in several stages in response to feedback and eventually settled on the six-layer architecture on the right. Here's a more detailed look at that model architecture, an example of what some input would look like into this model. It was trained on sequences of 20 words at a time and uses and predicts the next word recursively to generate poetry. The results of this were not very promising. After 15 epochs, the model stopped improving on the validation set and its accuracy began to go down. The word-based model was barely able to scratch 12% accuracy and fell below our baseline model accuracy of 7.3% after a few more epochs. Although this model did not perform well in terms of accuracy, the evolution of this model is still very clear. After the first epoch, the model barely outperforms the baseline by using a very similar strategy of guessing popular engrams. At 40 epochs, the predictions start to resemble actual poetry. For the purposes of this demonstration, the model wasn't shown Poe's most popular poem, The Raven, so we can use the poem's opening line to help gauge the model's success. After 200 epochs, this is what the model predicted with a validation accuracy of 6%. I would say this poetry is actually somewhat convincing. After creating such an egregiously overfit model, I changed gears to working with individual characters instead of words. This model worked the same way as its word-based counterpart, however, it had only 103 possible predictions to make instead of 24,000. Naturally, the baseline accuracy for this was much higher at 17.9%, but the model quickly surpassed the baseline and, to my shock, continued climbing until the accuracy plateaued at around 57%. This time, the baseline for this model predicted all spaces as the most common character in the corpus, and later learned popular bigrams like the most and the street. The model's predictions sounded more and more believable as the training went on. However, due to time constraints, the model was only ever allowed to train for 40 epochs. This is the model's result after 40 epochs, and I believe it could learn to produce more convincing poems with a few slight adjustments. In conclusion, neither of my models achieved the results I was really hoping for, but they each picked up on some interesting aspects of structured language and showed indications of successful learning. Both models struggled with validation accuracy, and the word model will most likely need to change drastically to perform better on that metric. That being said, the word model is still produced the most intelligible poems compared to the character-based one, and in the future, I would like to run more epochs on each of these on a more powerful machine, and maybe experiment with pre-trained weights from libraries like GPTJ. A quick demonstration of the Flask app associated with this. It takes in some text. Doesn't sound like Poe, but we can put that in, and predict the next 10 words from there. And it predicts this. It does have structure here with 8, 8, and down, down, and it did learn some things in terms of how poetry is written. So I would count that as a minor success. With more training, we can hopefully see better accuracy on this and more readable poems. Thank you, and let me know if you have any questions.